Good morning and welcome to this webinar to discuss the Energy Transition Commission's report on achieving zero carbon buildings, electric, efficient and flexible. This report is the product of about 15 months' work by the ETC and is one of the most important and comprehensive reports which we have produced. It does cover all of the issues relating to the decarbonisation of buildings. And today we are going to present some of the key findings, but not all, and then discuss them in a panel discussion. And I will be joined in that panel discussion by three people who are in the room here with me at Arup. And thank you very much to Arup for hosting this event. Those three people are Dervla Mitchell, a director of Arup, Stephen Richardson from the World Green Business Council, and Roxana Slavcheva, the global lead for built environment at the World Resources Institute. We will also hear in a pre-recorded a video from Greg Jackson, the CEO of Octopus Energy. Now, unfortunately, we had previously also advertised that Vincent Meunier from Schneider Electric would be with us. Schneider Electric are very active members of the ETC and very interested in these issues, but unfortunately, Vincent at the last moment has been unable to join us. One thing I should add right up front is to say that we will, after the panel discussion, have questions from all of you out there. Please do at any time start putting questions in the chat, and we will look at those and work out which of those to take. But early is good if you want to get yourself in the queue when we get to the Q&A. Now, buildings account for about 33% of all emissions from the energy, buildings, and industry and transport sectors of the economy. That's 12.3 gigatons. And you have to think about two different categories of emissions. There are emissions that result from the operational energy used when you're operating a building, whether it's the direct use of fossil fuels or the indirect use of fossil fuels to generate electricity. But there's also a crucially important, and that's 9.7 gigatons of CO2, but there's also a crucially important sector of emissions, which we call embodied emissions. And these are emissions that result from constructing new buildings. They're about 2.6 gigatons of CO2. They result from the production of materials like cement, steel, and aluminium, and from the energy used to construct the buildings. Also worth noting that there's another 2.3 gigatons in the construction of infrastructure rather than buildings, roads and ports and airways, airports, etc. When we are looking at operational energy use, it's important to distinguish 5 different categories of what we're talking about. We have energy used to heat buildings, whether residential or commercial. And a lot of that comes from the direct use of fossil fuels. So there the challenge is how do we go from fossil fuels to electricity, but also how do we improve the energy efficiency of buildings? When we think about cooling, lighting and appliances, most of the energy used to power that across the world is already electricity. So there the big issue is simply how much electricity, how great is our energy efficiency, but also how do we decarbonize the energy source? And then there is cooking. And here there is a fact which I know to some people in rich developed countries is surprising, is that while some cooking in rich developed countries comes from electricity and some from oil and gas, the vast majority of cooking across the world is actually done with what is called TUOB, the traditional use of biomass, charcoal and wood burning. As a result, when you think about buildings, we're not dealing with just one problem, we're dealing with many problems. If you can go to the next slide, please. And that means that this report is a long and complex one because this is a very big, complex, multifaceted challenge. The whole report, in fact, is about 250 pages long. But to make it manageable, we think about the building decarbonisation challenge as being 7 constituent challenges. 1, how to decarbonise heating of buildings. 2, how to increase access to affordable cooling in an efficient fashion. 3, how to improve access to clean cooking in particular. 4, efficient lighting and appliances. 5, how to decarbonise commercial buildings. Now, at one level, numbers 1, 2, 3 and 4, particularly 1, 3 and 4, are as relevant to commercial building as to residential, but there are some specific features of commercial buildings which look different from residential buildings. So we bring those all together in a section of the report. There's then a section of the report which deals with what we call buildings within a clean energy system, and in particular within a clean electricity system. How do we think in an integrated fashion about the issues to do with the demand that buildings place on the electricity system at different times of day, and also the fact that buildings themselves, through, for instance, solar PV, can be sources of electricity supply. And then the final of our 7 messages is that whole issue of embodied carbon emissions construction, and a huge opportunity across the world as we build new buildings to build them more efficiently, both in terms of how much carbon they went into them and how efficient they will be operationally. Now, we couldn't possibly in this webinar go through all of the material in this report, but I do please urge you to look at it. There is an enormous wealth of detail there. But what we're going to do is go through in 2 sessions. The first is going to focus on heating, cooling, and managing electricity demand. And that is really going to cover numbers 1, 2, 4, and 6 of these 7 possibilities. And then we're going to go through the whole issue of new build and embodied carbon. So to get us going, I'm going to hand over to Hannah Audino, who has led this work at the ETC, to run us through the key conclusions relating to heating, cooling, and managing electricity demand.
Thanks, Adair. Okay, I'm going to attempt to summarise our 200-page report in about 5 minutes. So let's start firstly with heating, where there are 3 sets of technologies that are required for zero carbon buildings. So firstly, those to decarbonise heating itself, where a whole suite of different solutions are going to be required across different buildings in different climates and different geographies. So various types of heat pump, electric heating, and various types of district heating and heat networks. Now, the common themes across all of these, they are mainly all electric, and they are all more efficient than fossil fuel boilers. We also have to think about how to create efficient and flexible buildings. So insulation, smart systems, rooftop solar, batteries and storage, all of these things are going to be crucial to improving living standards, lowering bills, but crucially ensuring that buildings can be an asset within a clean power system. Let's begin with the most important of those, and that's heat pumps, where the essence of a heat pump is you put in 1 kilowatt-hour of power and you get 4 kilowatt-hours of heat out. So heat pumps are multiple times more efficient than a gas boiler, making them a far superior solution with the potential for much lower running costs. But let's be clear, heat pumps are not just one tech. We have air-to-air, air-to-water, and networked ground source heat pumps. So there are heat pumps to suit different buildings, different household heating and cooling needs, and they're a very flexible solution. Now, we've seen a huge improvement in heat pump tech in recent years, so both improvements in efficiency and temperature limits, and those improvements are only going to continue along with falling costs. Now, we're very clear in the report that deep insulation is not a prerequisite for installing a heat pump, as long as heat pumps and radiators are properly sized and installed well. So insulation should not hold back the deployment of heat pumps, but it is still a really important part of the zero carbon buildings puzzle. And much of this can be very cost effective. So loft insulation, double glazing, these things will deliver a clear return to households over time. But of course, much of it does cost money and does take a long time for the returns to materialise. And so a clear role here for governments to provide targeted finance to lower income households. So what is holding all of this back? We have a whole section on this in the report. I'm going to focus today on the economics. So there are 2 parts to this. Firstly, the upfront costs. And these vary massively across countries currently. And there are actually many markets where air heat pumps are actually as cheap or even cheaper than a gas boiler to buy and to install. But of course, in many markets, they do still cost around double, especially air to water heat pumps to install. Now, we do expect costs to fall around 25% over the coming years, but it is a critical barrier that, of course, needs to be overcome. And so a key role for governments to provide low-cost finance and also for banks to provide mortgage top-ups and other innovative forms of finance there as well. The second piece of the puzzle is running costs, where heat pumps, being 3 to 4 times more efficient, have the potential to have huge operating savings. But currently, these savings in many markets go unrealised because electricity costs more than gas. And we see this clear correlation between heat pump deployment across countries in Europe and a lower ratio between gas and electricity prices. So rebalancing these is going to be absolutely critical. And there are actually many ways that governments can go about doing this. So shifting levies onto gas, general carbon pricing, and underpinned, of course, by appropriate power market design to enable low-cost renewables onto the market. So moving on to cooling, where a really key message from our report is that cooling is about more than just air conditioning. We have fans, evaporative cooling, and crucially, this whole suite of building and urban design techniques, which can really reduce how hot our buildings and our streets get in the first place. AC will, of course, still be the really main one here, and we expect demand for space cooling to more than double over the next 25 years, driven by rising incomes and also by warming climates. Now, cooling is already electrified, and so the key question here is really all around how do we manage that massive growth in clean power demand for cooling? And let's just firstly say that rising demand for cooling is fundamentally a very good thing. It's going to deliver huge health and equality and productivity benefits. But to reduce the challenges and the costs on grids, it's going to be really important to do 3 key things. So firstly, to improve the efficiency of AC sold on the market through much tighter minimum standards. Secondly, to drive more optimal use of AC, where we see these large differences in AC use across countries. So I think a really key stat that we love was that in Texas, the average household uses 4,000 kilowatt hours a year to run their AC. In India, it's 700. So policies to kind of promote more optimal use of ACs in richer countries can play a big role here. And then finally, we have this whole suite of what are so-called passive cooling techniques, which include a whole host of material and design choices that can really reduce how hot buildings get. And much of this can really be very cost effective, definitely in new builds, but actually especially in retrofit as well. So painting roofs white to reflect the sun, thinking about shading and ventilation. These things can massively reduce the need for as much AC, and also are going to be critical for those lower income households that are unable to afford access to air conditioning in the first place. So the other key challenge that we talk about a lot in the report is how do we balance rising demand for clean electricity and supply in a system based on variable renewables. The key challenge being when the wind isn't blowing and the sun isn't shining. Now we have a whole suite of solutions at a system grid level to help balance grids across weeks and across months of the year. So interconnectors, backup generation, long-term storage. But actually on an hourly and daily level, there are many things that buildings themselves can actually do to help balance grids. So insulation can reduce heat loss and therefore allow households to effectively preheat or pre-cool their homes ahead of peak times. Water storage, rooftop solar and batteries, these things can hugely reduce imports from the grid at peak times. And smart systems are really key to automating that flexible energy use. So flexible buildings are going to be key to reducing overall system costs and also carbon in the grid. To actually drive all of this, however, we need to see a much greater use and uptake of dynamic time of use energy tariffs, which offer households and businesses different prices across different hours of the day to give a clear financial benefit to shifting. So putting all of this together, this shows the massive increase in demand for clean electricity in buildings across heating, cooling, cooking, lighting, and appliances in 2050 from both demand growth, but also the electrification of heating and cooking. But also shows the potential to offset more than 80% of this increase with improving the efficiency of heat pumps, AC and appliances, better new buildings, and retrofitting existing ones. So a huge opportunity here, which we will now discuss.
Hannah, thank you very much for that clear exposition of some crucial messages from the report. We're now going to go to a presentation by Greg Jackson, the CEO of Octopus Energy, who are members of the ETC and are a company which have done a lot of thinking about this issue of how to balance supply and demand in increasingly renewable electricity systems and how to decarbonize residential heat. So if we can go to the video from Greg.
Is heating decarbonisation really that hard?
And the technology for heating decarbonisation is pretty straightforward. The vast majority of homes can be heated with an air source heat pump, replacing existing gas boilers. Blocks of flats and other buildings can be heated by communal heat pumps, like ground source heat pumps and so on. So basically, heat pumps can replace gas boilers to heat our homes.
What has Octopus's experience been in the UK and other parts of the world?
Octopus decided to really invest in heat pumps when we wanted to look at how do you decarbonize heating. Green hydrogen was one option, but it was just insanely expensive. Whereas heat pumps, every house has already got electricity, so heat pumps are the perfect solution. We've done a few things. So the first thing we did was build a research and development centre, which enabled us to test heat pump technologies and to train people to optimise installation so we can bring down the cost of installation for retrofit heat pumps. We've also invested in designing and manufacturing our own heat pumps, specifically to work well in the bulk of UK houses, the sort of 3 and 4 bed semis that so many people live in, and increasingly moving into terraced houses. Our heat pumps run at high temperatures, in fact, hotter than a gas boiler, so that if a gas boiler can heat your home, so can one of these. And our data now says that 91% of customers with a heat pump are happy with their heating system, but when we survey people with gas boilers, it's only 74%. So a heat pump has definitely been an upgrade. And there was recently a cold snap in the UK with temperatures, well below 0 degrees, repeatedly for several nights in a row, several times. And 86% of the customers with heat pumps said the heat pump performed with flying colours during that period. So Octopus has invested a lot, but we've only just started. Currently in the UK, there are fewer than 100,000 heat pumps installed every year. It's a huge increase on where it was, by the way, but we really want to be part of getting that to 600,000 per year over the next few years.
What are some of the biggest lessons learned?
Look, the biggest lessons we've learned have been that heat pumps perform at least as well as gas boilers, if not better for most people. They're cheaper to run on a smart tariff, so you can save a few £100 per year running a heat pump. And we found there's enormous low-hanging fruit to make installations more efficient. There's still some distance to go. For example, we want to keep on driving installation costs down. But with the government grants, installation is now broadly the same as a gas boiler. We'd just love to get to the point where through volume and optimization, we're getting closer to the cost of a gas boiler, even without the government grants. And of course, it's critical that the government improve the ratio of electricity price to gas.
What else would you like to see changed in the next decade?
Yeah, to be really clear, in the UK and so many countries, governments have got lots of levies on electricity they don't have on gas. And the UK's is particularly extreme, meaning gas is relatively cheaper than it should be, and electricity is relatively more expensive, and that could be rebalanced, and we call on the government to do that. But also, we want to introduce regional pricing, locational pricing in the UK, helping match supply and demand in each region all the time for electricity. And the reason that's so important is it will bring down electricity costs in every region. At the moment, we pay wind farms to turn off when it's windy, rather than selling electricity cheap. If we change the rules so that that actually brings down the price of electricity, of course, heat pumps become more efficient. It would also mean, by the way, we'd need less new grids. We could connect new renewables faster. We'd be building things like solar rooftop in the right places. The whole system will get more efficient. And finally, we would like to see all new homes built with heat pumps. It's kind of crazy in the UK at the moment. We build about 230,000 new homes, the vast majority of them with gas boilers, just building up billions of pounds worth of future costs to replace those gas boilers with heat pumps. That should be changed immediately.
To Greg for that message. And I'd now like to go to a discussion of these issues about heating, cooling and managing electricity demand here in the room. And I'm going to start with you, Stephen. I mean, as you listen to the messages of this report, what do you think is really required to actually deliver action in decarbonising buildings across the world?
Yeah, I first want to say congratulations to the team for delivering the report. It's a weighty tome. I do encourage you to dig through it and keep it as a reference. I think what comes through well and came through in the presentation we've heard is that we have so many of the solutions that we already need. We have them already, and so we're not talking about an R&D mission that we need to go on here. We're talking about a change management process, essentially. We need to change minds and practices, and the difficulty about the built environment in particular, which is I think a little bit unique to some of the other sectors that we think about when we think about the energy transition, is that there are so many minds to change. Europe alone has around 200 million buildings, so that's at least 200 million minds that we need to change and people we need to convince. So we need to give people both the means and the motivation to drive that change. The capacity needs to be there, the finance needs to be there, so that's the means. And in terms of motivation, we need to incentivize on the one hand, make it more appealing, make it financially more appealing, but also we need to mandate, and that's something that's really key. So how do we go about dealing with that change management process? We essentially need to align all these people at once. And one of the tools that we've found in our experience has been really valuable for doing that, for building that sort of community behind the transition, is essentially co-creating with local stakeholders a roadmap. And we've done that in Europe. We've launched 12 national roadmaps in Europe. We're working with WRI, Roxana from WRI here, on some more roadmaps. We've got Mexico and India underway at the moment. And this is an initiative that we are really sort of wanting to get behind, because we're seeing that it allows you to really create that community that will not just work on the technical issues, but will work on the policy issues and the financial issues and the social issues as well. And there's some great examples of how that's catalyzing change, which we can share as we go through the discussion. But it's a really exciting report, and great to see just the amplification that it gives us. And I hope that will really sort of inspire more to get behind that vision.
I think the point you've made about 2 points are really important. One is, we don't need brand new technologies. I mean, we need to drive up the efficiency of heat pumps, what's called the coefficient of performance, how many kilowatt hours of heat they can produce per kilowatt hour put in. And we need to improve the efficiency of appliances and air conditioners. But we're not seeing any need for fundamentally new technologies. The challenge is one of implementation, and we're very struck at the ETC by the complexity that you have suggested, Stephen, which is, when I think about how we decarbonise the UK's electricity supply system, the Secretary of State could get into one room the 150 people who need to make all the decisions of that, from National Grid, from the major suppliers, from the financiers who will support new grid or a generation developments. because you've just got a small number of decision makers. When we switch over to buildings, we are dealing with millions of decision makers who've each got to make a decision about what they do to their individual home. So really thinking through, and we try to think that through in the report, what are the policy mechanisms that enable that and make it easy for the individual are as important, even more important than the technologies, because as you say, we know what the technologies are. Now, Roxana, the focus in these reports, this sort of issue here in the UK is on heating. But across most of the world, most people don't need heating, they need cooling. So what do you think are the key messages we need to take out of this report on cooling? And what are the key challenges on making sure that cooling demand is met in a low emission fashion?
Thanks, Adair, and congratulations to the team putting it together. Really amazing job. Both on the making the case for kind of what we need to do, and at the same time kind of bringing in those illustrative case studies of the art of the possible, the things that are actually happening on the ground. So I'll build on what Stephen was saying, just because I do think that we know what we know, and where we're finding challenges in being able to address both on kind of the cooling side, but on any of these kind of initiatives and policy areas, is either we're missing the business case, or we feel that it isn't strong enough, or we're not putting the agency in the right place. And what I mean by that is that we're not enabling those 200 million or billions of people around the world to be able to kind of undertake some of those approaches, not just technology kind of enablers, but other approaches that they have kind of at their fingertips in order to be able to advance some of these solutions and to create an opportunity for scale. So one of those approaches, and I was pleased to see it was also highlighted in the report, is around being able to address kind of the affordable side of passive cooling. So we talk about, obviously there's going to be a huge demand, continuous kind of doubling for demand for mechanical cooling, and we want to avoid that. We do. I mean, we know it's going to happen, but we will do everything we can to be able to avoid it at all costs. And one of the ways we can address that is through these passive cooling techniques, approaches, methods that we have. And it goes back to kind of, taking ownership of those methodologies, of being able to work both on kind of the policy side, where we have governments in India, governments like those in India at this national level, that are taking their India cooling action plan and creating their own cooling action plan for the state. So Telangana is one example, and then we have worked in Kerala as well. In Telangana, for example, the business case is there. And I encourage you to kind of take a look at the report from a policymaker perspective and what you need to do in order to be able to communicate kind of what the benefits, the co-benefits, the actual practical steps and actions you need to take, and then the overall savings that you will have. So we know, for example, the passive cooling techniques such as Hannah mentioned, just simply painting, the roofs of the buildings white so that they are able to have this kind of, albedo effect and be able to kind of, basically just reflect the light so that it isn't kind of incorporated into the building stock itself and the fabric. That can reduce temperatures by 2 to 4 degrees Celsius. And there are a suite of other opportunities as well. But if we stick with that example, we know that, for example, it can reduce up to 20% of energy cost for that building. And then in terms of kind of other retrofitting measures that can only additionally kind of build on these savings. In Telangana, just to kind of expand on that example, they have done a calculation. The government's plan is to paint the rooftops for around 300 square kilometers of the entire state, or the many cities that need it, which are calculated to then equal to around 600 million gigawatts of energy savings per annum for the next 5 years. So we have the opportunity to kind of look into the agency, the business case. Is it kind of a double-edged sword where we're putting kind of the the emphasis on people being able to take this, or do we actually go in as a community? And I think that the second point that I'd quickly like to make is there are other opportunities that we're also not capitalizing on. And another one of those is nature-based solutions. So the opportunity for us to see what the impact of green space, specifically kind of larger areas of greenery, to have on the entire city, so that we don't just focus on one area. Being able to kind of, have those interventions on a larger scale is absolutely important, so that we embrace kind of, a more inclusive and climate justice equitable approach, and that we use what we have as an urban heat sink to address the urban heat island effect.
Thank you very much. I mean, the issue on which you focused, which is the importance of passive cooling, better insulation, things like green spaces, white painted roofs, I think is hugely important for a very particular reason, which is worth thinking about. We want as many people as possible to enjoy the benefit of cooling, but we want them to do that with as low an energy input as possible, because let's be clear, an energy input into a city warms the city. There's a big difference here between heating and cooling. If we put electrical energy into London or Stockholm in the middle of winter, we both put in energy, electricity, which turns into heat, and we shift some heat from one air to another. The net effect across all of the inside and the outside of the buildings is heating, which is okay. When you do the same with a cooling system, it is still the case that the net impact is heating. There is more heating being blasted out of an air conditioner outside a building than there is inside. And this, by the way, is a big issue about equity in countries where some people enjoy air conditioning inside and other people are out on the street being blasted with hot air. So in cooling, even more than in heating, we have to find ways by good building design, by good city design, to meet those cooling needs that we want to meet, but without increasing unnecessarily the energy demand, the demands on the grid, but also without unnecessarily heating up the entire city. Let me turn to you, Devlin. Perhaps you could give us a perspective on our ability to construct new buildings in a way which means that we have just a more efficient buildings able to provide both cooling and heating services.
Thanks, Adair, and thank you all for setting the scene so well. Before I go into some specifics about what levers I think and what possible things we could do, I think we all need, as individuals, and whether we're the 2 million people to be convinced, or the building designers or operators, we really need to understand the link between the climate change issues we see and our changes that need to take place in the built environment. And the second thing, which has already been said already very well, is that the technical solutions exist and the issues are around behaviours and incentives. So therefore we can do and should do going forward. Now, some specifics are, what are the levers that we have? We can move our buildings to all electric, and that transition is already happening in many new builds. And I think this report is very good in it also makes a positive case for heat pumps and probably demystifies some of those lingering doubts about their effectiveness. The next thing we should consider is how we operate buildings efficiently and effectively, and that is an increasing focus across the built environment. Remember, efficiency equals savings in money. And I think there's been a great focus on this with the energy issues that we faced in recent years. But we must also optimize the systems within our buildings. And by seeking these more optimized solutions, we can save up to 20% of the energy. And that is a fantastic step forward, but it also allows us to move into the stage where we're thinking about the reduced energy demand. Are we over-specifying equipment? And can we extend the life of our equipment, thereby reducing our carbon impact? We can also, as I think is outlined clearly in the report, look to the fabric of buildings and also maintaining a focus on passive solutions. So perhaps we need to move away from some of the enclosed buildings we have seen developed in more recent years. And then finally, I would say another area to explore is building regulations, codes of practice, and setting of really standards that stretch our industry and our sector to improve the performance of buildings. And that is not only good for the environment, but it also enhances the value of those assets for the building owners. So there's a few things that are specifics which we can help with in new build in the built environment.
Devla, thanks. So that's some thoughts on the issue of the operational emissions and the actual operation of buildings and heating and cooling. But we're now going to switch to the challenge also of those embodied emissions, which are also very important, and some of the complicated trade-offs that emerge between ways that you can reduce the emissions which result from construction, but also trade-offs between how you want to construct buildings in a way that reduce emissions when they are operational. So I'm going to hand back to Hannah now to talk about the scale of the new build which is going to occur across the world, and some of the ways that we can reduce the embodied carbon emissions, which will result from that construction. Hannah.
Thank you. Yeah, so thinking about the carbon embodied within new buildings, it is so important because we see this, global floor area is set to expand more than 50% over the next 25 years. And if there is no change and no improvement to lowering the carbon in this construction, this can create 75 billion tonnes of carbon cumulatively over the next 25 years. That's double today's annual global carbon emissions across the whole economy. So critical to address this kind of potentially locked in carbon. Now, the biggest sources of embodied carbon are the production of steel, cement and concrete. Now, with thanks to the Mission Possible Partnerships work, we know that it is technically and economically feasible to decarbonise steel and cement and concrete by mid-century with tech that we have available today. So the main ones being electrification, hydrogen, different cement chemistries, greater use of scrap steel and carbon capture and storage. But it will take time to fully scale all of this up across the whole world. And so it's going to be really important during the transition to think about other ways that we can reduce embodied carbon. And there are actually many ways in which we can do this. Now, embodied carbon is best addressed at the design stage, so before construction takes place. And we have a whole suite of design and material choices which can hugely reduce the material intensity of buildings. So shorter buildings typically use less materials per square metre. We can think about how to maximise floor efficiency for a given amount of materials, and even thinking about where buildings are sited and how to minimise the size of foundations. All of these things can hugely improve material efficiency without compromising on safety or quality. In certain regions, low-cost bio-based materials can also substitute and replace some steel and cement demand. And these can have a lower whole life carbon impact compared to steel and cement, where they crucially meet three conditions. So firstly, are they sustainably sourced? Secondly, can they store carbon during a building's lifetime? And thirdly, and critically, are they dealt with properly at end of life? We think the use of these materials will be very regionally specific, so depending on access to supply and local conditions, but they can make important contributions to reducing embodied carbon where applicable and appropriate. On a global scale, however, we do think there are limits to how far these materials can substitute a significant amount of steel and cement, given limits to sustainable supply and competing demands from other sectors. We can also think about how we can build less in the first place through avoiding high vacancy rates in countries like China, extending existing building lifetimes, and also better urban and spatial planning to kind of reduce that wider infrastructure build out as well. And where we do build, there is a huge opportunity to be more efficient in that construction and to reduce waste. So for example, modular construction. So finally, if we take that 75 billion tonnes of carbon that could be generated from building new floor space, if there is no change to construction today, and if we decarbonise steel and cement and think about how to use materials more efficiently, we can reduce that cumulative stock of carbon from 75 down to 30 billion tonnes of carbon. So a huge opportunity here, and we'll now discuss.
Hannah, thank you very much for a real whistle-stop tour of what is an entire chapter of the report on all these complexities of new ways of designing buildings, new materials that you can use, and then, of course, the crucially important issue of decarbonising the production of cement and steel, where we can't reduce the amount that we're putting into buildings. Let me go to the panel now. I'm going to start with you, Devla. When we're focusing on embodied carbon, can you give us an idea of what we can do and what we need to do to grasp that opportunity?
Certainly. Okay, I think we will gather from this panel that, you know, operational emissions are perhaps better understood and more easily able to address. And we will not get to net zero without reducing embodied carbon. Now, within the construction industry, the property sector, I think there's a very wide range of variation in maturity of understanding this and ability to address it. However, I would say that the UK is now leading and is routinely evaluating and optimizing embodied carbon in construction. And I think for this to be successful, we have to be really clear about what is measured, how it's measured, have agreed definitions, and have absolute transparency on those emissions or the embodied carbon. Ideally, if there was a clear performance floor that could be enforced and improved over time, that would allow us to make steps forward across the whole sector and across different geographies. So how do we reduce embodied carbon? Well, we start with doing really good design. And this is, I think, as a designer, I'd like to say something that's built into us is to do good, lean design. And many years ago, we would be asked by developers to design things that were 9 meters, 12 meter spans. Whereas today, this is becoming much more normal to do 5 or 6 meter spans. So those smaller column grids, thinner slabs, all can contribute to reducing embodied carbon. So that's a step we can all take. So that's me talking about structure, but on services, there's a lot more to do and to learn about those systems and how we reduce the embodied carbon. Low carbon materials is another opportunity to use those. And I have just heard this week that reusing raised access floor tiles is becoming a hot topic. This is not something I had envisaged, but it is becoming important, an important market, as is, there is also strong demand for low carbon aluminium, steel and concrete. So I think that those are all steps we can take forward to reduce the embodied carbon within buildings.
Thank you, Devla. And just before I turn to the other members of the panel, can I just remind you that if you want to ask some questions in about 15 minutes time, we'll be turning to questions from the floor. Can you please put the questions in the chat? Now, Stephen, it's a particular feature of buildings that is quite a regulated market, at least in developed countries, less so in some poorer developing countries, but pretty much all countries have, you know, rules on planning, rules on building regulations, and many of them have efficiency standards that relate to, you know, the efficiency in operations. How is that use of standards and regulations working? Are there difficult trade-offs between standards that could encourage people to, you know, make the building as efficient as possible in operations, but at the expense of bigger embodied ones? Can we get around that with whole life carbon? How do you see this tool of regulation and standards as enabling us to, as best possible, reduce emissions?
Yeah, it's a great question. I think Derval has mentioned how you can do a lot with, you know, just with efficiency, with reuse, and these are low or no cost measures. So it's really important that we keep that in mind and you know, doing the thinking early on so you can affect the design. These are all important factors, but I think, you know, most of our audience will probably be aware that actually it's quite hard to make the business case stack up for investing into low carbon materials. We talked to a lot of the manufacturers who are really struggling to sort of really get the demand signals from the market to invest into, whether it's decarbonising their cement plants, their steel plants. These are challenging things. And so where the business case is struggling, that's a market failure that needs to be addressed through policy. And we're seeing a shift. There is an appetite amongst regulators to tackle this. We've seen it with European policy, which is encouraging. We're seeing it in some states and regions in North America, again, encouraging signals. And I think what we're learning from that process is that there's one really key challenge that regulators hit very early on when they try and grapple with this, which is how do you set a target? You need a baseline, a benchmark against which to set your reduction target. And that often causes people to sort of throw their hands up in despair and say, oh, we don't have good data, we don't have the baseline data. But actually the lessons that we're learning from those markets that have gone ahead, and there are markets in Europe that are already regulated on a whole life carbon basis. So France has pioneered this, Denmark is another, there are other examples too. You don't need thousands of data points. They've done this with relatively small data sets. The data sets are improving all the time. You start with disclosure, that helps you build the data. And the European approach is taking that, is following that lead. So the Energy Performance of Buildings Directive has been updated. New requirements around whole life carbon are going to come into force, but it starts with disclosure. And there's an interesting sort of opportunity that we've identified where actually, because we've seen that those pilot sort of countries, if you like, with Denmark and France do this with relatively small sets of data, we've initiated a project called Indicate, where we're now working with teams in countries, bringing together different stakeholders to co-create that data. And in doing that, we bring the industry together with the policymakers, together with the academics, and that allows us to create a data set that has buy-in. Often we find that there's a lot of debate and wrestling about the data amongst the different parts of the market. We hear arguments between the steel and the concrete sector and the timber sector. They don't like how each other add their sums up, and we can get around all that if we can just bring people together and co-create these data sets. And that's a project that we're seeing now scaling. We've had three pilots. We've now launched it with another 5 with some EU funding. So it's an exciting opportunity. And I think what's really key is to find narratives that will be compelling, because we are seeing pushback. I'm sure the audience is aware that there is a pushback against green policy, against green standards. We need to create a compelling narrative alongside dealing with these more technical issues.
Thank you, Stephen. I mean, obviously that's a crucial issue. There is a pushback about green policies seen as regulation getting in the way of growth. One of the things which I think Greg made earlier is that the one thing one should also try and do is get it right first time in buildings. The fact that in the UK we are still building buildings with gas boilers rather than heat pumps, I think is something that we will deeply regret in future. If you get a building design right up front, you can reduce the embodied carbon and reduce the operational emissions far more cheaply than if you come back 10 years later and have to retrofit it. So crucially important. And Roxana, let's talk about how that works in the developing world. The developing world, which has an array of sophistication of building regulations, an array of the extent to which those are enforced, and also, of course, in an environment where people might be very worried about anything which increases the cost of buildings. How do you see that playing out, given that when Hannah presented those figures earlier of that huge increase, which we're going to see in the building square meters across the world, most of that is in developing countries?
Yeah, absolutely. I mean, half of the building stock that will be here in 2050 and quarters of the infrastructure is yet to be built. So it's a huge, absolutely massive opportunity to get things right, as you said, Adair, and as we heard, as early on as possible. And I think that it's, it's an opportunity. See, it's obviously a massive challenge, but it's also kind of an opportunity to think kind of in a more resource efficient way, to embed a lot of these standards that already exist in the market and to make them more mainstream. But as we know, the building sector value chain is quite complex. There are many different stakeholders to engage, convince, bring on board, and it actually creates kind of a lot of bottlenecks and all across the world in terms of just being able to set policies to get the right returns. And this lack of kind of standardized approach across geographies is something that we're kind of seeing over and over again. But there are some bright spots, and it's great to hear kind of from Stephen and others, how countries in Europe, and we know through our work in Colombia and Turkey, and now in Mexico and India as well, just to highlight a few of those example countries working in partnership with us to develop those roadmaps, to create kind of the policies and to set the right whole life cycle of carbon, both accounting, but just prioritization of actions approach kind of center in terms of the policies that they're doing. We also see that many of these goals to achieve, whole life cycle decarbonization really start at the subnational level. So over 80% of cities and regions, specifically in OECD countries, but in others as well, actually they have embedded higher efficiency, but also oftentimes embodied carbon building standards than their national level equivalent. And 25% of these also require buildings to become net zero carbon, so net zero energy. So it is even more ambitious than their national or regional averages. We see that in Helsinki, for example, where they had introduced their whole life cycle carbon regulation for new construction. A couple years before the national one actually kicked in. We see it kind of, across the board. But we see it in places like Bogota and Colombia, where they make sure that they align their guidance with the national government, but at the same time create their own action plans for building decarbonization to make a lot of these kind of, ambitious housing targets both affordable and at the same time fully decarbonized. And we do know that building codes, for example, are one of these kind of levers that are really impactful, and by a lot of kind of experts in the field are seen as kind of the lowest hanging fruit in terms of what we can do and what we can do now to kind of mandate, both on the efficiency side, but also on the design kind of material side as well, how we set these kind of codes in place. Many countries have voluntary ones. I think the World Bank recently released a database of kind of all of the countries around the world, and whether they have voluntary or mandatory building codes, whether they are, full life cycle, and it's a great kind of, comparison tool. There's a lot of work still to be done around mandatory ones, and there are multiple kind of examples of those who have gotten it right, and the power of kind of, the local government to be able to enable that further work. And I won't go into kind of different guidances that exist, but I think it's a great opportunity for us to think about how we bring a lot of the stakeholders on board, and that seeing how we have this not exactly a blank slate, but a massive opportunity to build half of the buildings that we anticipate in the next 25 years. There will be an increasing return if more people do it, as just mentioned, with the right incentives in the right way from early on. And that will also result in cost savings. And it's really about kind of how we get that message across.
Great, thank you very much indeed. And the subnational point is incredibly important, particularly in large countries like India. A lot of the lifting in terms of policies is done at the subnational level rather than Indian Union government level. And I think the balance between how much of the progress here we expect to see from national policy at more local levels is a very important one. Now, we're going to go in a couple of minutes to the questions. We've got a whole number of questions in, and Hannah and I are trying to have a look at them and decide which ones to take. Before that, I am going to do a rapid fire. I'm going to get 1 minute to each of the panelists to turn to say, what are the you're allowed 1, 2, or 3, but not more than 3, and you've got to keep them crisp. What would you actually like policymakers to do? Either you can be in a developed country or developing country within this decade, by 2030, which would make a difference, and as concrete and specific as possible. I'm going to go first to you, Stephen. What should policymakers actually do to drive this decarbonisation agenda?
Yeah, I think what's really important to recognise, taking that holistic global north, global south perspective, is that there are many countries that don't have mandatory minimum standards for their building stock. That's the absolute number one first thing, is that there needs to be policy. Without policy, nothing happens, or very little. So that's the first thing. I think the point Greg made about rebalancing, and it's made well in the report, rebalancing gas and electric costs is also really, really key in terms of decarbonising heating. And I think the third point that I would make is that we have to think about the holistic nature of the built environment. Buildings are so fundamental to our social fabric. They are where we live, heal, learn, play, work, and until we can really grasp that, you know, we'll just keep fixating on these technical issues and not win the sort of, you know, the battle of hearts and minds, as it were. So I think that's a really key piece, and we have a strap line that we use, which is be bold on buildings. I think for policymakers, there's a need to just take bold action now.
So bold is the one thing they're typically very worried about on buildings. They're much more willing to be bold on, I don't know, decarbonising the electricity system. We see it in the UK. There's a very bold policy to get to zero carbon electricity by 2030. We haven't yet heard the equivalent boldness on what we're going to do about buildings, but bold is good. Dervla.
Bold is excellent, and I would absolutely support that about mandatory requirements. But I think people have to see this as an opportunity, and it's an opportunity for, in the UK, we talk a lot about growth and development, to gain that growth, but to provide opportunity, skills and jobs for people. So everyone's got to see this as a possibility for them to grow and develop, not just for the nation to grow and develop. And I think there's another thing beyond, we're going to have to do some large infrastructure projects in every country, northern or southern hemisphere. We have to make, but when we do those major projects which will have carbon emissions, we need to make sure that we're looking at how we gain the co-benefits for communities, and I think has already been mentioned, for the environment. So much more holistic view when we're doing major developments.
Okay, thank you very much. Now, we're looking. Sorry, Roxana, I haven't given you your 3. I was my attention as I tried to think through what questions to take. But Roxana, please. Yeah.
I'll take all 3 then, since given the floor. I'll start by paraphrasing actually a quote from a WRI colleague of mine, where she works on circularity, and she says, you know, oftentimes we have kind of the wrong focus, so to speak, or maybe the wrong narrative. So we need nutrition, we don't need more food, we need mobility, we don't need more cars. And if we bring that to the built environment, we need more housing, not more construction. And if we do need more construction, more buildings, as we do in a lot of places around the world, we don't need the carbon intensive materials or overconsumption necessarily. So starting off with that mindset, where we're looking to sufficiency first, be my recommendation for policymakers to start addressing. That flexibility side that is also reflected in the report is very, very important from a design perspective as well. Then there is efficiency. We do absolutely have to continue to have the right codes, standards, everything in place to really continue to champion efficiency. And then finally, circularity, where we really kind of look into how we make the most of the resources that we have as well. I recently saw a statistic that actually, you know, it's as relevant in the global south as it is here in the UK, because it was a material index that said that approximately 88% of the UK's brick demand could be met if we actually reused rather than demolished our existing brick stock. So a lot of work for us to do in the UK.
Great, thank you very much. Now, we have about 15 minutes left, and we have a number of questions which have come through on the chat, and I'm going to take them in turn. Well, we've had to select out of them, but let me take some of them in turn. Some claim that heat pumps do not work in the UK as homes are not suitable for them. What do the panel members make of this? Now, I'm going to answer this question because I have recently put in a heat pump. And I have put it in a heat pump in a brick built cottage built in around 1900, which is not well insulated. I mean, we've done the obvious things and sort of stuff Hannah talked about, like roof insulation, double glazed, etc. Make sure that there aren't drafts, but it does not have cavity wall insulation. It's a single brick. We have not done solid wall insulation. And we haven't even increased all the radiators because we didn't want to have that aesthetic effect. We have increased some of the radiators and it works an absolute beaut. I think you have to get used to how you use a heat pump. You don't use a heat pump heating system by coming in at 6 o'clock in the evening from work and hitting the gas boiler on and expecting a surge of heat to come through the radiators. Though, as Greg mentioned earlier, increasingly you could do that with high temperature heat pumps, which, as he said, circulate at the same temperature as gas boiler systems. Heat pump systems on the whole are better used on a more continual basis, creating a broad background warmth. And of course, that is also the opportunity for you then to say, well, the one time when I'm not going to run them is when everybody else is running their heating system. I'm going to shift to another time of day. We think, and we set out in the report, that the evidence is that this idea that heat pumps only work in brand new passive houses or deeply re-insulated houses is greatly overstated. They still work, they still do that conversion of a kilowatt hour of electricity into 3.5 or 4 kilowatt hours in the house. They do that even if the house is only moderately well insulated. Still means we should have a very strong focus on insulation, both on heating and cooling, but we are very clear in the report that basically is one of these myths that we have now got to counter. Now, I've got a very specific technical question, and I want to see whether anybody wants to respond to it. It's a question about heating. Why did we not mention infrared heating? Dervla, you have, and the person who's answered it says this is a key form of heating. I think it's part of the wider set of sort of heating the person, not the room. Do you see that as a part of our suite of technologies that we should at least consider? I think we do mention it. We actually do mention it. We didn't mention it this morning, but we did mention these localized heat sources where, in addition to broad background warmth, you get a boost of heat in a particular area. Any thoughts on infrared heating, Dervla?
I don't have any technical current data, but for somebody of my age, that might have been, local heating might have been used when we were young. But at the time, it was very expensive. So I suppose I still have a mindset that that sort of local thing would be expensive. So I may be wrong on that in today's world.
Okay, I'm going to move us on from that. My own belief is that we may well end up seeing people in heating having, a broad background of warmth, but still wanting localized strong heat of various forms of radiative heating to just give them that boost in a particular corner of the room, and we shouldn't actually exclude that as part of the solution. One of the points we make in the report is that there are many different solutions, including this importance of resistive heating. I am going to ask the next question to you, Dervla, again, however, which is, somebody says, I'm interested in the heating transition in commercial buildings, including logistics warehouses. The presentation so far, a bit of a focus on the residential side. Can you make some comments on, what are the opportunities to reduce the energy load of whether it be warehouses or retail shops or, these things which are halfway between what we think of as buildings and industry?
Well, let me go to retail first. Do you notice, audience, that when you walk down your local high streets that most stores have their doors open? And when talking to people within the stores, they're asked by their managers to keep the doors open at all times to attract in customers. So I think there should be much more requirements for shops, retail units to keep their doors closed so they don't have this constant need to be heating the atmosphere outside their building. I think as the cost of energy rises, people running large warehouses will think much harder about the nature of their buildings and how they maintain temperature inside that. And we see that in those by having screens, heating at an entrance, trying to minimize the airflow through the building. So there are measures in place for those sort of buildings, which can be, I think, further improved through overall insulation.
Great. And then there's one issue which we do talk about in the report is really sophisticated HVAC systems, which you might be using in an efficient fashion to both cool one part of the building, but then using the excess heat from that to heat the water or heat another part of the building. Do you want to create a quick word on that, Hannah? Because it's an important part, I think, in the commercial buildings chapter of the report.
Yeah, I think there's a lot more, I guess, sophisticated things that you can do in the commercial building sector, and really thinking about the concept of, with cooling, that waste heat being a waste, and how do we actually really make the most of that and put that into heating other, a hospital, for example, that might have parts of it that require cooling and heating. How can we make those much more efficient and save significantly on running costs as well?
Now, somebody, Roxana, has asked, most of the solutions to reducing carbon emissions seem to be increasing the investment cost of buildings. Question whether that's right, but the question then follows, is that a big problem in developing countries? How to overcome this? Do governments have to subsidize it? Or is it not true? Are you basically saying if we get it right, we're getting lower emissions, but also lower costs? Can you talk about your experience looking at some of these developing countries? Is there actually a cost to be borne, or do we have a potential win-win here?
I'm an optimist, a proponent of the win-win, and I do think that we definitely have case studies and examples and enough evidence to be able to point us in that direction. I think it depends on kind of what we're focusing on. There does need to be an initial investment, whether that's from resources to financial investment or technical capacity building, because there are certain things that absolutely have to be addressed when we first kind of approach a retrofit or a new build to build to a certain net zero carbon standard, for example. But that first cost shouldn't be our objective or our whole kind of our whole kind of center in terms of what we're looking at, and we're seeing that first cost is the payback period, so to speak, the investment. That payback period continues to be shrinking now with kind of other advantages, other kind of cost savings that we're able to kind of bear. Can't give an exact case study or an example, but can definitely point you in the direction of several reports we have done around. We don't have to sacrifice affordability and decarbonization. That is definitely a dichotomy that we have proven over and over again that isn't the case. What we perhaps have to address is this short-term focus on the first cost and kind of the immediate resources that are required, and there are multiple solutions that we can help to ease the burden either on the consumer or on the government making those investments decision in the first kind of tranche, so to speak. But it's really about kind of the returns are there, and as I said, they are increasing over time.
The returns are there, but of course one of the big challenges we face on decarbonisation in every sector is these very big differences in the cost of capital between different households and businesses. And the more you go towards households and low-income households, they have a high cost of borrowing. So I think imaginative solutions to that are a crucial part of the story. Now, Stephen, you talked earlier about engaging communities, etc. And one of the questions is, in the area of heat pumps or heating more generally, how can community level solutions such as district heating or district heat pump solutions be pursued rather than always doing something on a house to house basis? In theory, there's a lot of potential efficiency in that, ground source heat pumps, networked of individual pumps, or district heating. Can you comment on the opportunity there and how we seize it?
Yeah, absolutely. I mean, I think what's important, the potential benefits are fairly clear and some common sense. You can scale, you can bring costs down through volume, you build capacity. I think what's key is that you need an aggregator. You need somebody to act as your coordinator of effort, and often that is going to be a municipality. I think local authorities, cities, doesn't have to be, but they have a key role to play in these kinds of neighborhood, district level scales. They have the mandate to do it. They have the resources in some cases, but I think there's a need for national government to work more effectively with local, give them the resources to play that role, and they can play a role both in terms of aggregating for demand and capacity building, but also in terms of aggregating at a financial level, which is really key in terms of deploying more capital. When we think about where the capital is, there is demand for green investments, but actually most of that tends to flow into larger projects, whether it's offshore wind, solar parks. It's easier to invest in these big infrastructure projects than it is to invest in small individual assets, and aggregating can help deal with that.
Okay. Very quickly, Hannah, I'm going to ask you this one question, which says, in Germany, city energy companies see the following problem with heat pumps: huge investments in electricity distribution systems to deal with peak demands. Can you just say a few words about, we have a very strong focus on this issue of peak demand within the report, maybe a few points on that, and then maybe the last question we're able to take.
Absolutely. So yes, it is. Investing in the distribution system is a key barrier that we talk about in the report, and it's not just buildings, it's also EVs that is driving that need for investment. And it's true, the system has to be sized to deal with peaks, even if they happen only on a couple of days of the year. Firstly, let's just say here that within the realm of electric heating, a heat pump is by far the better solution than electric radiators, which are 3 to 4 times less efficient. So the more that we can put in heat pumps over resisted heating, the better. The very fact that heat pumps operate differently to gas boilers for being left on for lower for longer means if you actually look at the size of the overall energy peak compared to a gas boiler, it's significantly less than it would be within gas. And of course, we talk about in the report the suite of demand side flexibility levers that buildings can provide to enable those shifts to be reduced. So, for example, insulation being the really key one here. Rooftop solar and batteries to enable households to meet some of that peak demand themselves, and also water storage, which is a really low cost and easy thing that should be done, to massive share of heating demand that can be effectively heated at off-peak times and stored for longer. So a realm of things that buildings themselves can do to mitigate those peaks.
Okay, I think we will have to conclude at that time. Thank you all for joining us. We hope that we've given you an idea of what is in this building report. Please do, for those who want to go in detail, to the 250-page full report, or to the executive summary, or to the explainers and brief summaries of the 7 key messages that we have on our website. But let me thank Dervla for allowing us to be here at the Arup offices. Thank Dervla and Stephen and Roxana for being with us, and thank you all for listening in to this webinar.